So the first thing I always do is all these sinusoidal functions, you guys, you have to just understand that they're based on circular things. So it could be based on a tire, or it's based on a Ferris wheel. It's based on something that goes around in a circle, okay? So the very first thing I always draw, before I even read one of these questions, is I'm going to draw myself a circle, and I'm going to split it into 4 parts. Now pretend that that's 4 even parts. It's not the best drawn circle. Now you have to decide also right off the bat if it's off the ground. All right, so you have to decide, is this thing on the ground or is this thing above the ground? If it's a tire, it's usually on the ground, I would say. Ferris wheels, this one's not, this one is the strangest Ferris wheel ever, just so you know. Most Ferris wheels are not directly on the ground because your legs be broken off. So this Ferris wheel is breaking your legs off, or else maybe you're entrapped or encased in the whole Ferris wheel thingy, and your feet are in it, and therefore you're not breaking them off. So I'm going to choose that to be the way that this one works, so that you're not all getting your legs ripped off. Okay. So most of the time Ferris wheels have a base, so I would draw a base. This one doesn't. Just keep that in mind. Okay. So each of these spots on the Ferris wheel is going to be a coordinate. Okay? Most of the time, if it's a Ferris wheel, you're getting on at the bottom. Or unless someone's transporting you to the middle. I don't know. But most of the time, you're getting on the bottom. And you're going to get yourself a coordinate here, and a coordinate here, and a coordinate here, and a coordinate at this stop. The coordinates are time, then height. Time, then height. Time, then height. Time, then height. Why is it time is the x and height is the y? Because it's always like that. It's always time along the x-axis, height along the y, right? Okay, so let's go through and let's see if we can come up with stuff to fill in here. A Ferris wheel has a diameter of 100 meters. So diameter is great, but I like radius better because radius is going to split it up a bit, but that's fine. So the diameter of this Ferris wheel is 100, so I'm going to make this be 50 meters and this be 50 meters. And the reason why I split it up into radius is because it's going to help me get those middle points if I split it up into radius as opposed to diameter. It takes 20 minutes to go around the Ferris wheel once. It's important to know how long it takes to do one revolution. So it's 20 minutes because we're going to split this whole thing up. This whole thing is 20 minutes, right? It's a slow-moving Ferris wheel. So you're in a very slow-moving Ferris wheel. However, it is 100 meters high, so I guess it's not that. It's just a really large Ferris wheel. Okay, so this is going to be 0 minutes, and then this point here again is actually going to also be at 20 minutes. Because when you're at 0 minutes and at 20 minutes, you're going to be right back to that same spot, right? The Ferris wheel takes a whole 20 minutes to repeat itself. We agree? Now, we're going to take this Ferris wheel and we're going to split that time into 4. Why are we going to split it into 4? Because we split the Ferris wheel into 4 stops, technically. We're going to pretend that we stop here, we stop here, we stop here, we stop here. Okay? So what's 20 divided by 4? 5. Thank you. So every 5, we're technically pretending we stop. Okay? So at 0 minutes, we stop here. Then at 5 minutes, we're going to stop here. Minutes. I'm going to put minutes. Just, what is that? Thanks, Smartboard. Okay. 5 minutes, then what would this one be? 10 minutes. And this is going to be 15 minutes. And this one's going to be 20 minutes. And this would be 25, 30, 35, 40, 45, 50, 55, 60. I could keep going, correct? And that would get me how many points? A whole bunch of points, wouldn't it? Okay. Then can we fill in the height of these? Well, we need to know how far the Ferris wheel is off the ground. That's our key thing here. So the lowest point where you enter the Ferris wheel is 0 meters. So once again, we're hoping that you're encased and your legs aren't getting ripped off. So this is going to be 0 meters. Okay? So this point is also going to be at 0 meters, correct? How high is this point? 50. Now, what people mess up is, if this is actually like 1 meters, you're getting on at 1 meter instead of 0, what would the height of this one be? 51, not 50. Okay, everyone always says it's just this middle piece, but remember, if you actually didn't get on the ground level at 0, say this was 1, you get on, this would be 51, and this would be 101, correct? It wouldn't be just 50. So this one is going to be at 5 minutes, I'm at a height of 50, because I climbed up 50 meters. At 10 minutes, I'm at how many meters? 100, because I got on at the ground. This one, I'm back down to 50. And then this one, I'm back down to 0. Do you see if you draw these out, you get points, little coordinates. So at 0 minutes, I'm at 0 meters. At 5 minutes, I'm at 50 meters. At 10 minutes, I'm at 100. At 15, I'm at 50. At 20, I'm at 0. And that's just going to keep following this pattern, right? So 50, 100, back down to 50, back down to 0. Okay? We can do a scatter plot of this, and it'll show you that it actually draws the whole thing out sideways. So any type of thing that goes in a circular motion over time will actually make a sinusoidal graph, and I'll show you this. So if you plot these points here, we're going to get 0, 0, and then 5, 50, 10 and 100, 15 and 50, 20 and 0, 25 and back up to 50, 30 and 100, 15 and 50, or 35 and 50, sorry, and 40 and 0. So if I connect these, anything that does circular motion over time will get you this sinusoidal graph. So that's why all of your word problems in a sinusoidal unit is something that's moving in a circular motion over time. Okay? Always. Has to be. So we know how to do regressions. Y1, or list 1, sorry, not Y1. List 1, list 2. Go to your lists, type this into your calculator. Do that. So stat, edit. Type. So when you calculate it, you're going to go stat, edit, put it in, and then you're going to go stat, calc, and the ones we've used so far that could be on your diploma are number 4, which is linear, number 5, which is quadratic, number 6, which is cubic, number 9 and 0, exponential and logs, and then C, which is sine reg. You picked ln. Need sine. So stat, calc, C. Sine reg.
Oh.
That typed in? Okay. Thank you. So we're going to calculate it, and we get C. So we're finding a sinusoidal regression. So we're going to find stat, calc, sine reg. Now, let's think about this. If they give us the regression, they want us to come up with a sinusoidal equation, and you're finding the quadratic regression. Does that make any sense? No. The linear, no. The cubic, no. The quadratic, no. Like, find the one that they're asking you to do. Now, always, when you're doing a word problem, your calculator needs to be in radian mode. Do you notice how, like, all the time we have it in radian mode? So, good idea. So we need to write the equation. So it's going to be y equals, they said A is 50. Sine 0.31415922654 x minus 1.570796327 plus 50. Now, what happens if on the diploma this wasn't in a decimal? They had it in an exact value. What could you do? Take your exact value, turn it into a decimal, see which one matches. Correct? We could do that. Or we could also find this correctly. 1 revolution. 1 revolution equals 1 period. 1 revolution is 1 period, because once you take 1 revolution and you get back to the top, what's going to happen now if you keep going? You're going to repeat yourself. And the moment you start repeating yourself, it's a new period, correct? So 1 revolution is the period. So if I wanted to find the exact value for B, I could go B equals 2 pi divided by the period. What was the period of this equation? How long did it take to do 1 revolution? 20 minutes. So I go 2 pi over 20, which is, B equals pi over 10. If you punch pi over 10 into your calculator, you're going to get 0.31415992, blah, blah, blah. Okay? So if they wanted the exact value, you could find it by just dividing 2 pi by how long it takes to do 1 revolution. Okay? Now, get that into your equation. Change your window. Remember, you have yourself a table. Your window's very easy to make once you have a table. What do? You look at your x-axis and you go, hey, 0 is the lowest it goes to because it's time. And then I go to 40. Make it be 40, 50, 60, whatever. And then your height goes from 0 to 100. So make your y min be 0 and your y max be 100, right? So you can see it. Everyone do this. You're going to do this because you're going to be asked questions about these. Okay? You're always asked questions about your regressions. So make sure you can see it on your calculator. If you can't and it looks strange, either your window is off or you have it in degree mode. So change your window so it's between like 0 and 50. Yeah. So you're going to change your window to be between like 0 and 50 and your height between 0 and 101 if you want. Okay, so you can see it. Can everyone see it? Now I can ask you questions. I can ask you an X question. So what does that mean? If I ask you an X question, that means I have to give you a Y. Okay, my Y is going to have to be between 0 and 100. So I'm going to ask you a question now. I'm going to say, at what time? Oh, no, I should say, what is the first time Sometimes they'll say, what's the second time or the third time? So you have to pay attention. Because if you think about it, your graph is doing this, correct? It keeps going. And if you're going to throw a y value through it, what's going to happen? It's going to cross a whole bunch of times, right? So they could say the first time or the second time or the third time, and you really have to think, what are they asking you? So what is the first time the Ferris wheel is at a height of 15 meters? So what is the first time the Ferris wheel is at a height of 15 meters? If I were you, I'd be writing this on that sheet of paper that I gave you. Did I give you that sheet of paper? Oh, this is funny.
Yeah, we haven't yet.
So what is the first time? It's a really good question. What is the first time the Ferris wheel is at a height of 15 meters? So did they give you y or did I give you x?
Gave us one.
I gave you y. What do you do when you're given y? Put it into, where can you put y in? In your y2. So you're going to go y2 equals 15, and you're going to look for the first time after 0 minutes that it crosses 15. So you're going to second trace 5, enter, enter, enter. The first time it. So when you do that second trace 5, enter, enter, you get 2.5 minutes, right? If I asked for the second time, you would have went to the second one and just found out where they intersected. Or the third time, you go to the third one, right? That's the only way they can make it a bit harder. 2, I could give you the x and ask you for y. So I could say, what is the height of the Ferris wheel at 80 minutes? The moment that I make this number, this 80 minutes, be bigger than like 2 revolutions, people start not being able to get it. Why would that be? Because your window is like 0 to 40, or your window is 0 to 60 or something like that. And it can't find an x value if it can't see the x value, right? So this is 80 minutes. Minutes is the time, so that's x. So if your x max isn't 80, at least, your calculator can't find it. Yep. So you can go second, trace, value, x equals 80, and you're going to get y equals 0. Why would it be at 0 meters? Because every 20 minutes it goes back down to 0, right? So 20, it's back down. So 0, I'm down. 20, I'm back down. 40, I'm back down at the bottom. 60, I'm back down at the bottom. 80, I'm back down at the bottom. Okay?